Hey there, Math Wonders. In this lesson you will learn how to find x and y intercepts and interpret their meaning in real-world situations. You will also learn to use x and y intercepts to graph lines. Your I can statements are listed. I can find x and y intercepts and interpret their meanings in real-world situations, and I can use x and y intercepts to graph lines. Alright, so a couple definitions here. A y-intercept is the y-coordinate of the point where the graph intersects the y-axis. The x-coordinate of this point is always 0. So in other words, the y-intercept is the value of y when x is 0, because all points on the y-axis have x-coordinate of 0. Conversely, the x-intercept is the x-coordinate of the point where the graph intersects the x-axis, the horizontal axis. All these points have a y-coordinate of 0. Alright, so let's look at a graph and identify the x and y-intercept here. The red line appears to intersect the y-axis at point 0, 1. So that would be the y-intercept. Again, that's when x is 0. What is y? The graph intersects the x-axis at -2, 0. Again, that's when y is 0. What is x? So the x-intercept would be -2. Okay, fair enough. So you guys try this. Pause the video now and identify the x and y-intercept using the graph. Alright, welcome back. Let's see. We're looking for where the red line intersects the y-axis. That appears to be at 0, +4. That would make the y-intercept, 0, +3 rather. That would make the y-intercept as 3. And the x-intercept appears to be crossing the x-axis at -2, 0. So the x-intercept would be simply -2. So we're going to find the x-intercepts given an equation this time. So to find the x-intercept, we're going to replace 0, or replace y with 0, because remember the x-intercept is when y equals 0, and then solve for x. So in this equation, I'm simply going to plug in 0 for y, and then evaluate, and find my corresponding value for x, which in this case is 2. So the x-intercept is 2. In other words, when y is 0, x is 2. Likewise, to find the y-intercept, I'm going to replace x with 0. So I'll put 0 in for x. I'm going to evaluate, and I solve for y. Finding y is -5. So the y-intercept is -5. So given an equation, we're going to plug in values for x and y, plug in zeros for x and y to find the subsequent x and y intercepts. Let's try another one. To find the x-intercept, I'm going to replace y with 0 and solve for x. And that gives me an x-intercept of 4. To find the y-intercept, I'm going to replace x with 0 and solve for y. And that gives me a y-intercept of 8. Okay, you guys try. Using this given equation, find the x and y-intercept by plugging in 0. Alright, welcome back. So hopefully you plugged in, to find the x-intercept, we plugged in 0 for y. That gives us ultimately -3x equals 30, which gives us an x-intercept of -10. Likewise, to find the y-intercept, I'm going to plug in 0 for x. And that's going to give me y is 6. The y-intercept is 6 when x is 0. So let's look at a word problem now. Trish can run the 200-meter dash in 25 seconds. The function f of x equals 200 minus 8x gives the distance remaining to be run after x seconds. Graph this function and find the intercepts. What does each intercept represent? So, since neither time nor distance can be negative, we need to choose several non-negative values for x. And then we'll use the function to generate ordered pairs. So we need to consider the reasonable domain and range when we solve word problems. So I'm going to plug in values for x of 0, 5, 10, 20, and 25. And I notice that as the time is elapsing, f of x is decreasing. Does that make sense? Well, if we're comparing time to the amount of distance left remaining, then yes, that would make sense. So now, given my table of ordered pairs, we can graph those ordered pairs. And connect them to make our line. And you see they do intersect the x and y axis at specific points. So then our job is to interpret what do those points mean. So the y-intercept is at 200. This is the number of meters Trish has to run at the start of the race. When she begins, when time is 0, she has to run 200 meters. The x-intercept is 25. This is the time it takes Trish to finish the race, or when the distance remaining is 0. So time is 25 when distance is 0. Check out another one. The school sells pens for $2 and notebooks for $3. The equation 2x plus 3y equals 60 describes the number of pens, x, and notebooks, y, that you can buy for $60. Graph the function and find its intercept. Once again, we can't have negative pens or notebooks, so we're going to choose several non-negative values for x. I chose 0, 15, and 30, and subsequently, the reason why I chose those numbers, I know that I'm finding 2/3 of a number. Now notice that I did rewrite this equation. I rewrote it in y equals form. Oops. I rewrote it in y equals form since we're plugging in values for x, and that was what was recommended in the last lesson. Since I'm plugging in values for x, I want to know what y is, so this makes it a little more efficient. So when x is 0, y is 20, x is 15, y is 10, and x is 30, y is 0. I'd like to have at least 3 points, 2 points minimum, but 3 points is better. So let's graph our coordinates. We find that the x-intercept is at 30 and the y-intercept is at 20. In the context of this situation, what do those intercepts mean? Well, an x-intercept of 30 is the number of pens that can be purchased if no notebooks are purchased. 0 notebooks, you can purchase 30 pens. Likewise, 20, the y-intercept of 20 means you can purchase 20 notebooks if you purchase no pens. And then we have all kinds of combinations of pens and notebooks in between those values. So remember to graph a linear function. You need to plot only 2 ordered pairs. It's often simplest to find the ordered pairs that contain the intercepts. Little hint, you can use a third point to check your line. Either choose a point from the graph or check it in the equation, or use the equation to generate a point and check that it is on your graph. Okay, that third point is just a kind of confirming point. So we're going to use our intercepts to graph the line described by the equation. Now in this case, this is written in standard form. So we're going to start by finding the intercepts, and we can do that as simply subbing in my zeros for y to find x, and then subbing my zeros for x to find y. Fair enough? Then we're going to graph our line. So if I have our 2 intercepts, like I said, I only need 2 points to make a line. So my 2 intercepts are located at 0, 3, and 7, 0, negative 3, I'm sorry, 0, negative 3, and 7, 0. I can connect those. And I could test, if I wanted to, I could test another point that appears to be obvious on the graph here. Perhaps, it's not very clear, but maybe 2, negative 2. and I should be able to sub that into the equation. Okay, now you guys try. Use the intercepts to graph the line described by the equation given. Pause video now. Alright, welcome back. So hopefully you identified the x and y intercept by plugging in values or 0 for the x and y coordinates rather. When y is 0, it appears that x is -4, or rather positive 4, and when x is 0, y is -3. So we can use those two intercepts to graph the line by plotting 4, 0 and 0, -3. And then we simply connect those two intercepts to make our line. Let's try one more. Use intercepts to graph the line described. This one is in y equals form already. I'm going to plug in so what I'm going to do first is rewrite this in standard form, so when it's x plus y form, and that's going to make it a little easier when we're finding our intercepts. So in this case I'm going to add x to both sides to get x plus y equals 4. So now when I plug in 0 for x and 0 for y, the computation is a little more efficient. So I'm going to find the intercepts by plugging in 0 for y. That gives me simply x is 4. And then I'm going to plug in 0 for x, and that gives me, hey, y is also 4. That means that when I graph this line at 4, 0, 0, 4, it's going to look something like this. Alright, you guys try this. We got y equals 1/3 x minus 2. Remember, rewrite it first in standard form. Alright, welcome back. So in standard form, I want to get x and y together on the same side. So in this case, I'd have to subtract. Actually, you know what? I'm going to go ahead and get rid of that fraction by multiplying both sides by 3. Get rid of that denominator. That gave me 3y equals x minus 3, x minus 6 rather. Then I'm going to bring the x to the left side by subtracting x from both sides, and that's going to give me negative x plus 3y equals negative 6. So you may not have gone about that route. You might have subtracted 3x, 1/3 x from both sides, but as it is, we should have ended up with negative x plus 3y equals negative 6. Then I'm going to plug in 0 for y to find the x-intercept. Now careful here, this is negative x equals negative 6. I don't want to know what the opposite of x is. I need to know what x is. So I need to find the opposite of, or take the opposite of negative x, which is positive x, which means I have to take the opposite of negative 6, which is positive 6. Likewise, we're going to plug in a 0 for x. This one's a little more straightforward. 3y equals negative 6, thus y equals negative 2. Take those two intercepts, and let's graph the line. Connect your dots. How'd you do? So in this lesson you learn how to find x and y intercepts and interpret their meanings in real-world situations. You also learn to use x and y intercepts to graph lines.